after you practice section 8.1, which I gave you 20 formula for an integral, either use the formula or modify it to suit the formula, and it doesn't work. You have to apply a different approach. This is 8.2. It's called integration by part. This is another technique of taking integral of a function. So if u and v are function of x and have continuous derivative, then an integral of u dv is equal to u times v minus an integral of v du. So you might want to remember this formula. Alright, so let's look at our first example. I have an integral of x e to the x dx, and I'm going to use an integral by part. So you might want to make sure that you want to write in the form of u dv. So there are two terms. One of them have to be u, one of them have to be dv. So I usually use the complicated one to be the dv. So the complicated one is x between x and e to the x. E to the x is more complicated term. So I'm gonna let my e to the x dx be dv. And another hint is the dv is always contain the dx from the original function. So if my dv is equal to e to the x dx, this is my dv, then my u has to be dx. So I have u dv from here. Alright, so if I take an integral of dv, I just get my v. Integral of e to the x dx is just e to the x. Now if you take derivative du, you're just gonna have dx. Alright, now we're gonna follow the formula. This is the original one. This is your u dv. Alright, so you have u dv right here. So it's gonna equal to u times v. So your u is x times v e to the x. Just follow the formula. Minus an integral of v. So our v is e to the x. Then du. My du is dx. Alright? Alright, so integral u dv equal u times v minus an integral of v du. Alright, fit the formula perfectly. Now, the first term here, you don't have to do anything. It's just x times e to the x. Minus, if you remember an integral e to the x, it's just e to the x. And then don't forget plus c. Alright, very straightforward. Now let's look at the next example. I have an integral of x cosine 4x dx. Again, I want to write it in two terms. One have to be u, one have to be dv. So I picked the more complicated one to be my dv. So the complicated one between x and cosine of 4x would be cosine of 4x. So my dv will be cosine of 4x. Again, dv, we want to have dv contain the x from the original function. So my dv is equal to cosine 4x dx. If you take an integral on the left hand side, you just get the v. Again, I need the 4 here because derivative of 4x is x. So I have 4, and then I have to multiply by 1/4. So my v is just 1/4. Integral of cosine of 4x is sine 4x. Alright, so this is my dv. X has to be u, because one of them have to be u, one of them have to be dv. This is already dv, so this have to be u. So x equal to u equal to x, du would equal to dx. Now we're gonna put in the formula. I have u, alright, dv. Alright, so it's gonna equal to u times v. So my u is x times v. My v is 1/4 sine of 4x right here, right? Minus an integral of v. All right, what is my v? My v is over here. So 1/4 sine of 4x du. All right, so my du is dx. All right, I substitute in the formula, an integral of u dv is equal to u times v minus an integral of v du. All right, the first term here, I don't have to do anything. All right, so I'm gonna have x over 4 sine of 4x. That's the first term. The second term, I'm gonna take out the 1/4. All right, I'm gonna take out the 1/4 because I'm allowed to take out the constant. Then I'm gonna have sine of 4x dx. Right? So what am I missing here is the derivative of 4x. So I'm gonna put 4 here, multiplied by 4. If I do that, I have to multiply by 1/4 because 1/4 times 4 is 1. Okay? So from here, I'm gonna have x over 4 sine 4x minus 1 over 16. Right? Now, an integral of sine is negative cosine. All right? Negative cosine 4x. Negative and negative will become positive. So this is my final answer. All right? Let's look at the next one. All right, the next one, see, I have an integral of x squared sine of x dx. Same idea. I want to write one of them as u and one of them as dv. The complicated one here will be my dv, which is sine of x dx. Take an integral on the left hand side, you get v. An integral of sine, you're gonna get negative cosine. So my u, this term have to be x squared. Derivative of x squared is 2x dx. Alright, so I have an integral of u dv is equal to u times v minus, just follow the formula, an integral of v du. Right? Now the first term here, I just put a negative up front. So it's get negative x squared cosine of x plus, because I have 2 minus here, so it become plus. The 2x, I bring it up front, that's okay. So 2x times cosine of x dx. Now what I did is I take integral by part again for this second term here. Alright, the second term here I'm doing integral by part again. Again, cosine of x become dv, so dv equal to cosine of x dx. You take an integral, you're gonna get v. An integral of cosine is sine x. My u will be 2x. Derivative of 2x is just 2 dx. Now we're gonna substitute it in. The first term here, I'm just write it down, right? I'm just write down here, right? So you're gonna have plus, all right? U times v, so u times v minus an integral of v du again. All right, so I'm just rewrite everything. Next step, I just bring the 2 up front because it's a constant, and I have an integral of sine x dx. An integral of sine is negative cosine. Then negative times negative is positive. Again, don't forget the plus c. So that is my final answer. All right, I'll see you again next section.